here's the problem. Jose, mass of 66 kilograms, is skydiving towards the ground. When he deploys his parachute, he experiences an upward acceleration of 11.1 meters per second squared. What must the drag force be created by his parachute? So while that sounds very simple, there's a lot of things that you need to do first. So the first thing you need to do is draw the object and probably label the forces too. That probably actually comes before the other step. Then you're going to identify the direction of the net force. Here's a new step. We haven't done this one yet. You got to label your positive direction. Then you're going to label what the net force is. You're going to find it. And then once you've found the net force, you're going to find whatever it asks you to find. So in this case, it's asking you to find the acceleration. Okay, so first things first, we draw the object. So here is Jose skydiving. Here's his parachute. There we go. Only the best drawings for you guys. Okay? Then we label his forces. His forces are gravity pulling him down. And the normal force, sorry, not normal, tension or drag, whatever you want to call it, pulling up. All right, so we drew the object, we drew and labeled the forces. Now we got to identify the direction of the net force. So I ask myself, what direction is the change? Well, when I pull a parachute, it's going to slow me down. And it says there's an upward acceleration. So if the acceleration is up, then my change is up. So I'm going to draw an up arrow off to the side and just write F net next to it. Again, I don't know the value for F net, but it's helpful to have the direction of F net. Helpful to have the direction. Okay, I've got the direction of F net now. So now I'm done with step 1, I'm done with step 2, I'm done with step 3. Next thing, I'm going to label the positive direction. I'm going to decide what direction I want to be positive, just like you did with free fall. It is up to you. I have a suggestion. My suggestion is whatever direction motion is. That's my suggestion. So my motion is down, so that's going to be positive is down. Just draw an arrow, put a plus by it. That's all I need. Now, if you're saying to yourself, but Mr. B, I like up always being positive, then hey, do it. Make up positive every time. Okay? Make up positive every time. I'm fine with that. Just be very careful about directions. Be very careful about directions. Okay. I've done steps 1 through 4. Now I'm ready to find the net force. Okay? So how do I find the net force? So the way I find the net force is either by doing F net equals MA, or by adding the forces together. So I look at my problem and I say, what is it that I know? I know the mass and I know the acceleration. Those are the only values that I'm given. I'm not given any forces. So I say to myself, self, if I need to find the net force, I'm going to have to use what I'm given. And so what I'm given is F net equals M, which is 66, times A, which is 11.1. And that gives me 732.6. Now, remember I said be careful, be careful, be careful, be careful. I called down positive, but my net force is up. That means I need a negative acceleration, which means I need a negative 732.6. So be really careful about that. Then you would have a positive, and that's fine. Yep. Okay. So now I found that. Now I'm ready for the last step. find the missing force or the acceleration. I'm looking for a missing force. That missing force is drag. So net force equals the force I'm looking for plus gravity. Well, here's the problem. I don't know what gravity is. Didn't give it to me. There's one more thing we haven't done yet. The last thing we haven't done yet is use this last equation, Fg equals mg. All I have to do to find the force of gravity is multiply the mass by g. And if you've forgotten, g from previous units is 9.8. No, good question. It's only going to be positive, no matter what you call positive direction. This is always going to be a positive 9.8 because this is just a scalar. It's just a value. It's not the direction. The direction comes from the picture. So I need to find the force of gravity. So I'm going to do that here. Fg equals mg. So 646.8. And that's what I put in for Fg here. Again, be careful about directions. I called down positive, which means this is a positive 646.8. If you called up positive, this needs to be a negative 646.8. Yeah, because it's in the opposite direction. Yep. Because you called up positive, right? Yeah. So that's why this would be a negative 646. So you will be adding it. Yep. Yep. Mine's positive, but yours would be negative. So I'm going to subtract it to the other side. And that gives me a final answer of negative 1,379.4. And there's your problem. Again, if you called up positive, you would get a positive answer, which is totally fine. But you should get the same number. Should get the same number. If you didn't get the same number, go back and check your signs. Go back and check your signs. And there you have it. So these are the steps. These are the steps to solving. The only thing that's new that we hadn't done yet is this Fg. You only need to find Fg for vertical motion. You don't need to find Fg for horizontal motion, unless I ask you to, but I generally will not. Okay? Questions on the example? Okay, I'm going to turn you loose here. Get as much done as you can. Get as much done as you can. Some of you have already gotten started. Awesome. For sure, you should finish the front page. For sure, you should finish the front page. So I'll leave this up here. I'll give you a minute to get started, and then I'm just going to come around and answer questions. Come around, help out, answer questions, talk to y'all, see what you're able to do. If you need to come back to this example,